For this question, we want to sketch the graph of the following function and identify all properties that apply. We're going to start with sketching the graph, and then we'll take a look at those properties. So to sketch the graph, I'm going to make a chart, a table of x's and y's. And I like to choose a standard set of x's, -2, -1, 0, 1, and 2. And substitute those into the function to get the y's. So if I substitute in a -2, that would be -2 squared is +4. -1 squared is +1. 0 squared is 1. 1 squared is 1. Let me back up because 0 squared is not 1. 0 squared is 0. 2 squared is 4. And this gives me a set of ordered pairs that I can plot to kind of sketch my graph out of. So we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. I'll plot these points on my graph. 0, 0, 1, 1, 2, 4. -1, 1, -2, 4. And what I see as a pattern is a U-shaped graph. This graph is called the parabola. And it looks like this. So there's a sketch of the graph. And now I want to go through these properties to see if they apply. The first property says this function is an odd function. An odd function has origin symmetry. So a graph or a function that has origin symmetry will have a mirror image going over the origin. So that means that your picture in the first quadrant would be a mirror image in the third quadrant. And if you have a picture in the fourth quadrant, it would be a mirror image in the second quadrant. And you can clearly see in our picture that our third quadrant right here, this is quadrant 3, is completely empty. And yet we have points in the first quadrant. So this function cannot be an odd function because we don't have a mirror image in these opposite quadrants. So we would not check that first statement. The next statement says the function is a linear function. A linear function happens when you have your variable to the first power. Our variable is squared, so this is not a linear function. Let's see the next statement. So the next statement says the function is increasing on the interval from -infinity to infinity. As I look at this graph, starting from left to right, my y values are decreasing along this section and increasing along this section. So my function is not increasing from -infinity to infinity. It's decreasing along this section on the left, which is from -infinity to 0, and it's increasing on the section on the right, which is from 0 to infinity. So this statement does not apply. The next statement says the function is an even function. An even function is a function that has y-axis symmetry. So when a graph has y-axis symmetry, you would have a mirror image folding along the y-axis, meaning that everything that you have on the right, you have a mirror or reflection on the left of the y-axis. The graph that we have here, if we draw a line along the y-axis, you can see that you have a mirror image on the left and right of that y-axis. So we would check this property to be true. The next property says the domain of f is negative infinity to infinity. I'm going to take my ruler and hold it vertically and think about when is the first time my ruler would hit the graph. Because of this line going on forever, it's going further and further left the higher and higher we see it. The domain would start at negative infinity, and because of this line it's going further and further right, the domain would stop at infinity. So my domain on this example would go from negative infinity to infinity, and so this property is true. I would keep that one. The next property says the range is negative infinity to infinity, so I'm going to hold my ruler horizontally and go from bottom to top. The first time I hit the graph wouldn't be until I get to a y value of 0. So for this function, the range starts at 0 and continues on to infinity, and so I would not select this property. The final one says none of these properties apply. Since I've selected 2 of them, I wouldn't check this one either. So the 2 properties I would select is that this function is an even function and the domain is from negative infinity to infinity. In this problem, we want to sketch the graph of the following function and identify all the properties that apply. So let's start by sketching the graph. In this function, we have f of x equals negative 4. And if I were to build a chart for this and choose my standard set of x's like negative 2, negative 1, 0, 1, and 2, I can see that this equation doesn't have an x variable in it, and this is what we call a constant function, meaning that the y is constant no matter what the x is. So we would get a y value of negative 4 no matter what x you choose. So my ordered pairs would be negative 2, negative 4, negative 1, negative 4, 0, negative 4, 1, negative 4, and 2, negative 4. The y is constant no matter what the x is. So these are the ordered pairs that I would get. And we can see that our graph is a horizontal line. So then let's take a look at each one of these properties. The first property says the function f is an even function. So an even function will have y-axis symmetry. So as I look at this y scale, I want to look at both the left and the right of the y scale to see if there's a mirror image. And there is a mirror image, so I would check this feature. The next property says the range of f is negative infinity to infinity. The range is the y values, and you can see that the only y value that we have is negative 4. So the range consists of a single point, and that's negative 4. And so our range is not negative infinity to infinity. The next property says the function f is a linear function. This is a linear function because the graph is a straight line. I would check linear function. The function is increasing on the interval from negative infinity to infinity. For this function, the y values are constant. The y values never increase, never decrease. They are constant for every value in the domain. So this function is not increasing, and I would not select that property. The next one says the domain of f is negative infinity to infinity, and you can see that every x value is covered. If you want, you can hold your ruler vertically and move that ruler from left to right, and you can see that your graph starts at negative infinity and continues all the way to positive infinity. So the domain of this is all real numbers, negative infinity to infinity. The next property says the function is an odd function. An odd function has origin symmetry. So origin symmetry would be reflecting, have a mirror image around the origin. So opposite quadrants would have a mirror image. So if I look at quadrant 1 versus quadrant 3, you can see quadrant 1 has no piece of the graph in it, and quadrant 3 has a piece of the graph, and so these are not mirror images of each other, and so this function is not an odd function. The last statement, none of these properties apply. Since I've selected some of them above, we would not check this box. Thank you for checking out my videos. Have a great day.